Greetings, dear children. So, today let's continue with the coordination chemistry chapter. Now, the topic which we are going to discuss today is going to be important for 1 mark question in the CBSE board examination class 12th. Let us understand how to do the nomenclature of compounds, coordination compounds. Nomenclature means naming the compounds. So, we have the formula over here: CuNH3 twice H2O twice Cl2. So, copper is the central metal atom or the ion over here, and we have got ligands like ammonia, which is a neutral ligand; water, it is a neutral ligand with a charge of 0; chloride, it's a negatively charged ligand with a charge of -1. So these points should be clear, that the charges on these species has to be learnt and has to be remembered. So we begin with alphabetically placing the ligands, and they are actually placed alphabetically in the formula also. So we start writing diamine because ammonia will be called as amine. So diamine. Water is also 2 times, but it is called as aqua. So it is diaqua. Di means 2. Mind well, there is no space between there will be no space, so try to keep them very close. Then chloride is also 2 times, so we should write its name also as dichlorido. And after that, we are keeping a slight space over here, as you can see, and then write that copper, since it is in the neutral neutral part, that means there is no right hand side or the left hand side part, this will be called as copper. Okay, so whenever the central metal atom is in the positive part of the complex, or it is a part of a neutral complex, then we will name it as the metal itself. Otherwise, if the metal is in negative part, like for example in this example, you can see that it is iron is coming on the negative part on the right hand side. So in that case, we have to name that metal not as iron, but we will name it as ferrate. So whenever there's a negative part, then you will call it as ATE. Let's go to let's check whether now what we have written is correct. So copper plus 2, amine 0, water is 0, and chloride is -2, and plus 2 minus 2, yes, so this is correct. In the second example, iron is the central metal atom, water is a neutral ligand, it is a monodentate ligand, its charge is 0. Chloride is a counter ion because it is written outside the square bracket, its charge is -1, so -1 into 3 is -3, and therefore iron has to be +3 because water is 0. So the total answer of this will come as 0. So with that knowledge, we will be naming this compound as 6 times, that is hexa. Aqua means water, and then we write iron as iron because it is in the positive part of the complex, and chlorine is in the negative part of the complex. So this will be iron, and 3 because 3 was the oxidation state, and chloride. The next one, in the next one, cobalt is the central metal atom or ion. Then you can see ammonia is the neutral ligand. Then the point which is very interesting is that in this case there are two ions, both are complex. The cation is a complex and the anion is also a complex. Okay, so this is going to be a very special kind of complex compound. So there are two metal atoms here. One is cobalt, which is the central metal atom, central metal ion in the case of the cation, and chromium, which is the central metal ion in the case of the anion. But in the first coordination entity, ammonia is 0, and in the second coordination entity, NO2 is -1, which gives rise to charge of -6 because NO2 is -6, and we have chromium is mostly 3, so we get an answer of -3, and therefore this entire complex also will have a charge of +3, and therefore cobalt is also +3. So remember that chromium and cobalt are very special metal atoms. They have generally the charge of +3, so you can use them. to create your own formulae in the exam. Let's write the name of this. So here it is 6 times. Remember, cation has to be named first. So we are writing hexa, that is 6 times amine, cobalt, and then 3 because the oxidation state of this cobalt is 3. And then we have to leave space. There has to be space over here, right? And then we write down hexa nitrito N. So what is this nitrito N? Remember, we could also have written it as nitrito O had this been written as ONO 6 times. So if we write it as ONO 6 times, it means that the oxygen is the connecting atom. But presently in this formula we can see that it is NO2 written, so that is nitrogen is the connecting ligand, connecting atom of the ligand. So it is written as NO2. So when you write nitrogen in the beginning, that means nitrogen is the connector, but when you write ONO and in that oxygen at the beginning, then oxygen is the connector. So please remember this point. So it will be nitrito N, and then we write chromium, not as chromium but as chromate, because chromium is in the negative part of the complex and then the oxidation state. The next one is again potassium is the central metal, sorry, it is the counter ion because it's outside the square bracket. The coordination entity is this particular thing which I am encircling. Iron is in the central metal atom. Nitrosyl is another ligand which is 0 charged, it's a neutral, and cyanide is negatively charged, so it's -5, and you all know potassium is +3, so you must get an answer of -2 out here. So you give this iron the oxidation state of +2. But since this is in the negative part, this is a negative part, that is negative complex, and this is a positive simple cation. So potassium is in the positive side, but it is a simple cation. But this entire part, which I can write it as FeCN5NO, this is a negative complex ion, and its charge is going to be it's going to be -3. Yeah, it's going to be -3. So let's write the name potassium. This is potassium because it's a cation, and leave space. There has to be space over here in the paper also. Then 5 times cyano, so we write it alphabetically, we are going because C comes first and N comes after that alphabetically. So pentacyano nitrosyl ferrate 2. The next one, now in this we have a very special ligand, that is a polydentate ligand EDTA, that is ethylene diamine tetraacetate, and we are naming it as ethylene diamine tetraacetato. We are writing it as acetato because it is in the negative part of the complex. It's not in the positive part, it's a part of a complex anion. So the name would be sodium. We are not writing disodium, so whatever is outside the square bracket, we need not indicate their number. So if it is Na 4 times, we will not write it as tetrasodium, we will just write it as sodium. Similarly, if aluminium is outside the square bracket, we will write it as aluminium. But if aluminium is inside the square bracket, then yes, we have to write it as trialuminium. Right now we'll write it as sodium. Then we leave some space over here because between the cation's name and the anion's name there has to be a little gap of around, let's say 0.5 centimeters, and then we write it as ethylene diamine tetraacetato nickelate 2. How did we get this 2? Because sodium is +2, EDTA is -4, and therefore this will be -2. EDTA is -4. How does EDTA look like? We have already seen in the previous sessions, but I will show you again. So what you have to draw is 4 times acetate. So CH2CO minus, you will start drawing it on all the 4 sides. Okay, and after that the lone pairs are also there. So the donor sites are number 1, number 2, number 3, number 4, number 5, number 6. They might ask you this in exam. The next one. Now in the next one you can see there is a cation and there is an anion. Cation is simple but the anion is complex. Okay, so the name would be ammonium's charge is +1, so it is +3 because it is 3 times, and of course obviously this has to be -3, and oxalate is -2, so -2 into 3 -6, and this has to be +3. When you write down ammonium and then you just leave some space between the cation's name and the anion's name, and then write down trioxalato. You're writing it as oxalato. Cobalt is not written as cobalt, but it is written as cobaltate because it's in the negative part of the complex. 3 is the oxidation state and ion is written. Now this ion we should not write because it's not an ion, it's a complete complex. The next one is this, it's an ion because you can see that it's not having anything on the right hand side, it's just an ion with a positive sign, so we are writing it as ion. Now cobalt is a central metal ion, bromide is a negatively charged monodentate ligand, nitrito N is a negatively charged monodentate ligand, ethane 1,2-diamine is a neutral bidentate ligand. So when we write the name again alphabetically, bromine's B and ethane's E has to be seen and nitrito's N has to be seen. Do not consider the bis, the B of the bis. Okay, it's just a prefix, it's not used for seeing the alphabetical sequencing. So when we start writing the name, the negatively charged ligands will be ending with ido, o kind of thing, right? So that way, so it becomes bromido bis. Why are we writing bis? Because this ethane 1,2-diamine, it has already got the di prefix in its own name, so to indicate its number we'll have to use bis. Bis indicates 2 times. It's a Greek word, bis means 2 times. So bromido bis ethane 1,2-diamine, then nitrito O cobalt 3 ion. So we're writing cobalt not as cobaltate but as cobalt because it's in the positive part, and then the ion. Next one, it's again an ion. We can see that it has got a charge of +3, so we mentioned the word ion. Then here in this case platinum is a central metal atom, nitrito N is negatively charged, ammonia is a neutral ligand. So start writing the oxidation state first. This is 0, this is -1, and as you can see here the answer is written as +3. So accordingly we will have to write down the charge on this as this is -1, so it will be +4 because you want an answer of +3, right? So now alphabetically the A and this is N, so alphabetically amine should be first. So pentamine, nitrito N, platinum 4 ion. We are not writing platinum as platinate because it is not in the negative part of the complex, it is in the positive part, so this will not be written. The next one is very simple again. We have central metal atom or ion is cobalt here, chloride is a monodentate negatively charged ligand, ammonia is a neutral ligand, chloride is a counter ion over here. So when we write alphabetical sequencing is important. So amine A, chlorido C, so the name would be 4 times amine, that is tetraamine, then dichlorido, and then cobalt. We are not writing it as cobaltate because it is in the positive part of the square bracket, it is not in the negative part of the square bracket, so or negative part of the complex, so it will be cobalt 3 chloride. I think yeah, the next one is again we have platinum is a central metal atom, chloride is a negatively charged ligand, ammonia is a neutral ligand, chloride is a counter ion, so we'll be writing it in the same way, pentaamine because amine is 5 times, chlorido, platinum 4 chloride. How did we get the oxidation state? We start with chlorine first, -3, this overall is +3, this is 0, this is -1, so this has to be +4. Next one, again NO2 is -1, so you always start with that ion which is outside the square bracket and then do the rest of the calculation. So water is 0, ammonia is 0, this is -1 into 2 is -2, and this has to be +3 because +3 and -2 will give you the answer of +1, and +1 and -1 will give you the answer of 0. So alphabetically A, AM, then AQ, then N. Okay, remember that. So we have pentaamine. Now this cannot be pentaamine because we can see it's 4 times, so this penta will be removed. We will write tetraamine, then aqua, then di, because NO2 is 2 times, so dinitrite to N, close the bracket, it has to be in the bracket, chromium 3 nitrite. Yes, NO2 is nitrite. Let's check whether what we have done is correct. Yeah, it's absolutely correct, because it is 2, 4, 5, 6, 7. Okay, there is some mistake in this, so we will rectify that. Why? Because chromium cannot have 7 ligands around it, because we have 1 water, we have 4 amine, and we have 1 NO2. So instead of writing 3 ammonia, we'll write 3. 4 ammonia, we'll write 3. So this should become triamine. Let me draw the structure and show it to you so that you understand what I am talking about. So chromium 1, 2, 3, 4, 5, 6, and then I start placing this NO2 2 times, ammonia 3 times, and water 1 time. So, and then of course there's a square bracket and the charge of +1. Okay, next one, this is an interesting one. Again, ethane 1,2-diamine is neutral, and there's an overall charge of +3, so cobalt also has to be +3. We're writing tris because En is a complex, it's a ligand in which already the di prefix is used. So to indicate the number of such a complex ligand, we have to use Greek prefix. So tris means 3 times, tris ethane 1,2-diamine, cobalt 3 iron. Next we have again here chromium central metal atom, ammonia 0, this is 0, this is -3, this has to be +3, therefore chromium is also +3. So triamine, because 3 times ammonia, then triaqua, because water is 3 times, then chromium 3 chloride. The next one, again it's a negatively charged ion, so iron will be named as ferrate. So this 2+ should not have been here, so its name will be, iron is a central metal atom. This iron, okay, I think there is some error in this formula, so let's rectify that. So we'll write it as Fe, and then the square bracket, FeCN6, and this will be, that's the formula. Okay, so let's now analyze it. So cyanide in this case is -1, so -1 into 6 is -6. Let's assume that this is +3. So if it is +3, then this will be -3, and this will be just iron, because iron will be +3. So we can write it as FeCN6 -3. So iron will be written as iron hexacyanoferrate 2. Ferrate, it will not be 2, it will be 3. The last one. Now here we have the central metal atom is iron, oxalate is -2, and this will be, sodium is +3, right? So we can have it as +3, this will be -3, this is -6, this will be +3. So when we write the name, it will be sodium, then trioxalato-ferrate 3. So I think that's the end of our writing the names from the formulae. In the next session we'll see how to write the formula from the name. With that, we'll just end the session. So keep revising, and all these are taken from your NCERT textbook, and many of them have been asked in the board exam also. Thank you so much. Great day. Bye bye.